Okay, so lesson 2.8, starting it today, finishing it tomorrow. Depending on how much we get through, you may or may not be able to really do much in the way of homework tonight. But lesson 2.8 is solving inequalities. We just came out of solving equations and some reviewing there. But 2.8 is solving inequalities. Now, not solving the basic linear inequalities, but solving the more complicated inequalities. And so that's what we're looking at. We're going to look analytically. We're going to talk about some algebra. We're going to talk a lot of graphically. So, in fact, I'll give you more specific details about which ones you're graphing and whatnot in homework probably tomorrow, because we won't get to the graphing part today. So, okay, example 1. We're going to talk about just figuring out, it leads into our inequalities, where a polynomial is 0, positive, or negative. And so we're given a polynomial, f of x equals x plus 3 times x squared plus 1 times x minus 4 squared. It says to determine the real number values of x that cause f of x to be, and we're going to do 3 different options here. When this function is 0, when this function is positive, and when this function is negative. Let's start with A, because A is kind of the old news piece to this. When this function is 0, in other words, for what x values does this cause f of x to be 0? No. Save those for example 2 tomorrow, or today if we get a chance, but negative 3?
Oh, 1, negative 1, and 4.
I partially agree.
The 4's right. 4.
Okay. So, okay, where are these answers coming from? You guys are throwing out some random answers. Well, not random, but some answers. Where are they coming from?
The parentheses. What will make the parentheses?
Yeah, what will make the parentheses 0, right? So this is, you guys, when does this equation equal 0? Well, when you can put the value in that will cause that parenthesis to be 0, right? So the shortcut is if you set x plus 3 equal to 0, then we're going to have a 0 at x equals negative 3, yes? If we set x minus 4 equal to 0, we're going to have a 0 at x equals 4. What about x squared plus 1? What happens when you set x squared plus 1 equals 0? Subtract 1 over. X squared equals negative 1. Take the square root. Square root of negative 1, which is I. And what did this problem specifically say? The real number values. So yes, there are technically zeros at plus I and negative I, but that's not what we're talking about today. We are talking about real number values. Okay, so for A, x equals negative 3 and x equals 4 are the zeros. Okay, so those are the values of x where my equation will equal 0. On the graph, if we graphed this, these are the places where my graph what?
Touches the x-axis.
Crosses the x-axis, right? Or crosses. I always say crosses the x-axis, but officially it's crosses, touches, somehow touches the x-axis, right? Okay, now, while we're here, let me throw in a little bit of review, and it will lead into what we're going to do. Can you tell me the multiplicities of each of these? Do you know the multiplicities? Okay, the multiplicity of negative 3 is 1. And why does that have a multiplicity of 1?
Because there's no exponent.
Yeah. The only exponent is the invisible exponent of 1, right? And x equals 4 has a multiplicity of 2 because there's an exponent of 2 right there, yes? Okay, while we're at it, what do those multiplicities tell me about what's happening on the graph? Where it touches or crosses the x-axis. So what happens at x equals -3 when there's a multiplicity of 1? It's going to cross the x-axis, and why is that? Right, because 1 is odd. If it has an odd multiplicity, remember my graph will cross through the x-axis. So what's that mean at x equals 4 when we have a multiplicity of 2? It's going to just touch the x-axis, and it touches because multiplicity is even. This is old news, right? Sounds familiar? Technically, it was on the last quiz. Not everyone quite had comprehended it yet, but it was there, I promise. Okay, so that takes care of A. What values of x cause this function to be 0? That's at x equals -3 and 4, which are also our x-intercepts. Now, when we talk about positive and negative, we're going to practice doing something called a sign chart. And in order to do a sign chart, I'm going to set up kind of a number line here. This is my sign chart I'm setting up. And on this sign chart, you're going to put your zeros on this sign chart, which my zeros in this case were -3 and 4. And notice I put them in numerical order, but I didn't worry about spacing or anything like that. Okay? I just want them in numerical order. If there's more than that, numerical order, I'm not worried about spacing. Yes?
And the reason we didn't use the middle parentheses was because that x had a square on it, correct?
Well, so that middle parentheses, x squared plus 1, it became an imaginary.
Right, okay.
Right? So like if we had done x squared plus 1 equals 0, subtract 1 over x squared is -1, so then it becomes x is plus or minus I,
Gotcha.
but our direction said real.
Gotcha.
Had that been x squared minus 1 in parentheses, we'd have a different conversation because that would result in real numbers. Does that make sense?
Yep.
Okay. But it's all cleared up now, right?
Yeah.
Okay. I mean, yes and no. Because we had the squared, yes, that's why it didn't get used, but it wasn't just because there was a squared there. There's more to it than that. Okay, so on my sign chart, aka my sign chart is a big long number line. That's all it is. I broke it up with my zeros. And what we want to know is what's happening in each section. So I want to know to the left of -3, is my graph positive or negative? Or is my function positive or negative? Between -3 and 4, is my function positive or negative? And to the right of 4, is my function positive or negative? So what we're going to do is we're going to pick some test values. What is a test value you would like to use to the left of -3? Okay, he says -8. It's a nice number.
We're not supposed to know.
Well, and here's the deal. When I say pick a number to the left of -3, what are we saying? He said -8. I'll be honest, I wouldn't have picked -8. Random, but I would have picked -4. Now, here's the deal. Does it matter whether we go with Jaden's -8 or Carly's -4? It doesn't matter. Any number to the left of -3 would get you the same results. I tend to just go with the very next number. -8 is perfectly fine though. Okay? So I'm going to say I'm going to use a test value of -4. And what we're doing with that -4 is we're going to plug it into the original equation into each factor. And I don't care what numerically the factors equal, I care what sign they equal. So when I put -4 in here, what do we know about -4 plus 3? It's a negative. Jaden's saying, oh, what do I know about negative 8 plus 3? It's a negative. Okay. Now put your negative 4 in your next parenthesis. What do you know about negative 4 squared plus 1? It's a positive. Jaden's going to say the same, right? Because when you square a negative, you get a positive. When you add 1, it's a bigger positive. So that's a positive. What happens when I put negative 4 in my last parenthesis?
0. Oh wait, no, it's positive.
Negative 4 minus 4 is going to result in a negative, but what's the catch? It's squared, so it's going to be a positive. What do you know about a negative times a positive times a positive?
It's a negative.
This results in a negative. This section of the graph is negative. When the x values are less than negative 4, my graph is negative. That means when if I graph this on the calculator, to the left of negative 3 is going to be below the x-axis. Okay? Now let's see what happens between negative 3 and 4. Pick a test value.
1.
Oh.
1.
I don't like any of your guys' values. I'm going to use 0. Miracles happen, right? Okay. I'm going to go with, I'm surprised. Your classmates didn't pick the easy 0 this time.
I forgot it was.
I thought Cody's-
1 is easy, but to me, 0 is always easier.
I
So
forgot 0 was there.
you forgot 0 was an option, right? Okay. So if we put 0 in, what do you know about 0 plus 3?
Positive.
Positive. And substitute your own number in, right? What about when I do 0 squared plus 1?
Positive.
It's a positive. What about when I do 0 minus 4 and then I square it?
Positive.
It's a positive. What do you know about positive times a positive times a positive?
Positive.
So this section of the graph between negative 3 and 4 is positive. Means my graph is above the x-axis here. Okay? Yes?
What if you would have gotten 0? Is 0 possibly?
You wouldn't get 0. The only way you would get 0 is if you plugged in negative 3 or 4. And we're not allowed to use those boundary numbers. Okay? And what about a number bigger than 4?
5.
7.
I'd go 5. You guys pick what you want. Hello.
Or 7?
Not quite, but almost. No, it's been like a minute or two. Okay. Bye. Office when we're done. To Christy. Okay. Did you guys try this one? I just realized I'm running out of time. I would test 5, test any number bigger than 4, right? When I put in that number. For me, I'm thinking, what do I know about 5 plus 3? It's a positive. What do I know about 5 squared plus 1?
Positive.
It's a positive. What do I know about 5 minus 4?
Positive.
It's positive, and then when I square it, it's still positive. What do we know about positive times a positive times a positive? It's positive. Now, think about it. Does this make sense? At negative 3, what was my graph doing?
Down. Starts down.
It was crossing. Does it make sense that my graph would start negative and cross and become positive here? Yeah. What did we have happening at 4? It touched. So does it make sense that if it stayed if it was already positive and it touches, it would stay positive? Yeah. Now, officially, I have not answered my questions here on B and C. B, when is my graph positive? We'll have to talk about this more tomorrow. On the interval from negative 3 to 4, union 4 to infinity. And C, when is it negative? Negative infinity to negative 3. We will remind me to start the discussion with why I wrote those answers down tomorrow. Okay?
Megan Connor, please come to the high school office.